Good afternoon, everybody. Thank you for attending. We're going to get the webinar started here. We have General Air today. It's myself, and we'll be presenting on some air supply decision and working through the different types of compressors that are available, and when it's good to use each, talking about leak rates and things like that in regards to nitrogen generators and such. Before we get started, a couple things I want to get into here. Oh, that's me. That's my email address. And let me just tell you two things. I mean, one, with the email address, please do not hesitate to reach out to me if you have any questions. Certainly, we'll talk about it a little bit more in a minute, but you can ask questions here in the webinar by typing into the chat. And we'll get to those as best we can. If there is something that you think about down the road, or a project comes up or whatever, I'm always very happy to talk about these things with anybody who's got questions and help to find a solution stuff. So please never hesitate to reach out to me. And additionally, you can call our 800 number for tech support and stuff. And I can tell you that you get a real live human being on the line who is capable of answering almost any of your questions. So please avail yourselves of the 800 number as well. And that goes for anybody attending this. Pass that along to your field workers. Any techs in the field can call our 800 number directly and get all the help that they need while they're in there, standing in front of a compressor or a generator or a dry air unit or whatever. Oh, this is new here. So we have Master Spec. We just listed all of our products in Master Spec, I want to say a little over a year ago, or just a little under a year ago. But what we just recently added to that was the Revit families. So we have Revit veilings available for all of our product lines: air compressors, nitrogen generators, air maintenance devices, residential equipment, dry air units. If you go to generalairproducts.com, you will find that. And also, I'm going to ask Dave Phillips here, my counterpart here in marketing, to post a link in the chat. So please do take a look at that. And that will make hopefully your lives a little easier as you're doing design work. And if you have any questions or issues with that, please just let us know. But we've had them out for a couple of weeks now, and they seem to be working really well. The last thing before we get started here is just this disclaimer for the NFPA. It's saying any opinion expressed is the personal opinion of the author and presenter and does not necessarily represent the official position of the NFPA and its technical committees. So you are forthwith disclaimed. All right. Today's webinar, we are, like I said, going to get into air supply decisions, and we're going to do that by way of dry and pre-action film technologies, what technologies are available, pros and cons of those technologies with corrosion in mind, since that is the hot topic, flow of air and nitrogen versus system leak rates, which is a really important aspect of this conversation. So we really try to fill you in on how these products work and how that functionality affects the system. We'll talk about how to determine which technology is best for your application. We'll get into a few sample applications if time allows, and then again, just kind of reiterating how to make a sound decision on your air supply. All right, without further ado, we will get started. Air supply decisions. So there's three main types of, say, sprinkler system or dry and pre-action. Just so you know, for the purposes of brevity, I always refer to everything as a dry system, so I mean dry and pre-action. But there's three technologies that are available: compressed air, nitrogen generators, and dry air generators. These are the kind of, we're going to take some top level look at these technologies and what they bring to the table. Because each of them comes with their own pros and cons, and each of them has situations that they're best suited for. It's not always cut and dry, and it's something that it takes some expertise to understand. We try to illuminate you as best we can here, but again, just remember that you always have us to rely on to have that discussion, to have to try to fill you in on what we think is best, because when it comes to air supplies, this is what General Air has been doing for a long, long time, and we offer all available options. So when it comes time to make a decision, you know, if we think an air compressor is going to do a better job given a certain scenario than a nitrogen generator, you're not going to have us forcing a nitrogen generator down you. You know what I mean? And same thing with dry air and nitrogen. If we think nitrogen is the best way to go, then we're going to tell you about it. You know, one of the things that we'll get to, but I mean, it becomes very cut and dry as to dry air being the absolute best choice for freezer rooms. I mean, so we'll talk about all that as we go forward here. So let's start with the lubricated style fire protection air compressors. They are more maintenance intensive than their oilless counterparts. Maintenance is key, and maintenance is something I'm going to come back to. I'm always shocked when I see some people in the industry saying, "Oh, like, you know," they just kind of skip over the maintenance aspects of what's required on these systems and on these machinery. Maintenance is key on any air compressor, any nitrogen generator, any dry air generator. Maintenance is vital to its longevity and performance. If you don't do maintenance, you will have these units fail on you. And I don't care if it's just an air compressor all the way up to the much more sophisticated nitrogen generator. They all need maintenance. And a quick kind of rule of thumb, when it comes to deciding between a lubricated compressor and an oilless compressor, the big decision maker there is maintenance. Will there be somebody to do maintenance on site for a lubricated unit? If so, then I highly recommend a lubricated unit. Somebody's going to change the oil, make sure that it's anchored properly, make sure that the motor and flywheel are aligned properly, things like that. And like I said, mainly the oil. Also making sure that the tank doesn't fill up with water, because when you compress air, you get water, and it collects in the tank. So somebody's got to drain that. So if somebody's doing all that, a lubricated compressor is a great way to go. If no one's going to be on site to do that, then an oilless compressor is more of a way to go. And that's offered in two styles, a tank mounted, and what you're looking at here is a riser mounted oilless air compressor. Now, oilless, again, and I said this before with maintenance, is every unit needs maintenance. So oilless is low maintenance, not no maintenance. So, you know, please be sure to check in on those. They can be neglected a little bit more than the lubricated compressors, but at the same time, they should be looked at on a regular basis. Just to make sure that they're anchored properly, make sure all the fittings are tight, make sure that it's operating the way that it should. And there's a bunch of kind of standards set in NFPA 25 now that govern how compressors should be looked at. That's a different presentation for another time. We will be posting something on codes and standards presentation again soon. I think we did one a couple weeks ago, so that'll be coming around the horn again. But oilless compressors, low maintenance, not no maintenance. The oilless riser mounted is by far the most popular one that we make. And what I would keep in mind, the one thing I try to tell everybody to keep in mind is if you have a high ratio valve or a low pressure valve, dry valve, or pre-action valve, then you need a low pressure air compressor. And that just it comes with a pressure switch that is set to work within the range that the valve requires. If you try to buy a standard pressure compressor and throttle it down at the pressure switch to work into a low pressure valve's parameters, it is not going to go well. You're going to have that compressor is going to short cycle and it's going to be all out of whack because the pressure switch is not meant to work within that, say, 13 to 18 or 2026. You really need the low pressure compressor. So for all you designers out there and everything, if you're laying something out, say with one of the Revit families and stuff, and you're dropping in, make sure that if you have a low pressure valve, you're using a low pressure compressor with it, not just a standard pressure compressor. And there's ultimately, they're the same unit except for the pressure switch. So the size and everything will be the same. And that's why it's important to get it right from the design stage all the way through, so that somebody doesn't go and try to put a standard pressure compressor with a low pressure valve and then start adjusting the pressure switch. It's really just going to cause nothing but problems. All right, this is the tank mounted version of the oilless compressor. And again, tank mount's always the way that I would recommend to go over riser mount. Even though riser mount is by far the more popular, tank mount, what it allows any tank mount, whether it's lubricated or oilless, you're going to have an air maintenance device with it, right? If you have one system, you're going to have one air maintenance device. If you have three systems, you're going to have three air maintenance devices. But with the oilless or lubricated tank mount units, what that setup allows you to do is to run them at their max, which is say 60 or 80 psi, and throttle that pressure down at the air maintenance device. And what that does is, with having more pressure on the compressor than you need in the system, will cause the compressor to run less frequently, which means that you're going to get a lot longer life out of that air compressor. So I can't recommend a setup like that enough. A tank-mounted air compressor with an air maintenance device is, to me, what should be on every dry valve and every pre-action valve, if possible. And then lubricated or oilless based off of what we were talking about before, who's going to do maintenance and such. Quiet fire protection air compressors came on the market about 5 years ago, maybe longer. These are a variation of an oilless style air compressor. They do come in riser mounting and tank mounting varieties, standard, low, and high pressure. The whole point of our design was so you couldn't hear it on the other side of drywall. So again, for any designers out there, I believe we have Revit files for this too. If somebody is, if you're designing something, you know that on the other side of the wall where you're putting that valve is going to be somebody's apartment or a dentist's office or some place where quiet is valued. I would highly recommend using a quiet fire protection air compressor. That said, if you're designing a loading dock and that's where the valve is going to be and that's where the compressor is going to be, then don't worry about the amount of noise. Nobody really cares how loud the compressor is on the loading dock, but they sure do if it's right outside of the wall of their bedroom in their condo or right on the other side of the wall in a hotel room and such. So things to keep in mind there. But and again, the reason I bring that up too is that what I'm trying to make the case for here, and it's a recurring theme as we go through the entire presentation, is there are certain scenarios where one technology is better than others. And I'm not trying to push the, say, a quiet air compressor everywhere, because you can save a little bit of money by having a standard decibel air compressor on a loading dock where no one cares how loud it is. But conversely, there's times where people will see the value almost immediately of an air compressor not running in their ear at 2:30 in the morning. And that would be, any of those places I would put a quiet fire protection air compressor. Another type of air compressor that we see in the field a lot, just to round things out, is a retail or non-fire protection air compressor. I can't recommend enough not using these in permanent applications. For starters, they all usually come with handles or they come with wheels or things like that. What the design of that unit is telling you is that it was not made to be permanently installed anywhere. They have a plug and cord, which is no longer allowed by the standard. They would go to a light switch, which is also not allowed by the standard anymore. Again, you can jump into our codes and standards webinars for that. But they have a very short life. Just a quick kind of word on that is most of the compressors that you find at Home Depot or Lowe's or something like that, Harbor Freight, Granger, they have about a 500-hour run life. A fire protection air compressor has a 5,000 to 8,000-hour run life. So you're talking about a dramatic difference between the two, the design philosophies behind the two. And again, it's because a fire protection air compressor is made to not fail for an extended period of time because of the nature of the application. What else? So, again, I don't say throw all these ones out. I mean, if they're installed somewhere permanently, certainly they should be replaced, in my opinion. But if you have one at your facility or in your office or on your truck or something, it is good to use as a temporary air compressor. If a compressor goes down, you've ordered a new one and you're waiting a couple days before it comes in, and gets installed, sit one of these there for a couple days. That's not a bad move. But outside of that, again, in any permanent capacity or semi-permanent capacity, I would just, be aware that it's not advised to keep these in place. We're going to skip that part for now and go to the next section where we're going to get into the different technologies as far as corrosion is concerned. So let's see where we're at here. Okay, good. So where corrosion is concerned, let's group all of our compressors together as one technology, compressed air or air compressors. The pros there are high airflow, lower cost, and longer lasting compared to the other technologies, specifically nitrogen generators and dry air units, dry air generators. The negative aspect is that, especially where corrosion is concerned, is that these contribute water and water vapor to the sprinkler system. When you compress air, you get water. The water that's in the air starts to condense, and it'll either collect in the tank, it'll collect in the piping, it'll get blown out into the system, causing corrosion. Now, how much corrosion that causes is typically, most of the time, it's very little amount, but it still is a contributing factor as opposed to an inhibiting factor. So that's why I call it out there as a negative. The high airflow is something that we're going to come back to, but the airflow that you get out of a compressor that's advertised on the compressor is the airflow you get into your system. And flow is what dictates the size of a compressor, how often it's going to run, and really, it is the most important factor when it comes to the efficiency and effectiveness of air supply unit in a dry and pre-action system. So what we're looking at here is the corrosion triangle. You have metal, and it's a very simplified overview of this. I really don't get into a lot of corrosion science. There's plenty of science out there, and there's actually George's brother Jim McHugh, who I steal his line when he's talking about corrosion, because I think that it's perfect, and that's that if you left your bike out in the rain when you were a kid, it rusted. Corrosion science lesson over. I mean, how much more do you need to know? When you have pipe and air and water, it gets wet, and you get rust. You get corrosion taking place. So there's a, you could, I'm sure, talk for up to about 6 hours or so about that. But I don't think that that we need to get into it much more than that. So this is a simplified version of the corrosion triangle: water, oxygen, metal. And just like the fire triangle, you eliminate one of the points on the triangle, you eliminate the possibility of that happening. So in this instance, we are not eliminating anything. We're actually contributing some water to the sprinkler system. So there's really nothing, we're not having any effect on the corrosion triangle as it stands. But one of the ways that I do recommend setting up a compressor for corrosion mitigation purposes is by using a product that I'm sure George will be talking about, which is their corrosion monitoring device. They call it their Core Insight. I believe I just really like the way that it's designed to operate mechanically, and yeah, this is a really good way to approach, I think, corrosion if you're not sure that you have a corrosion problem, or if you're concerned about having a corrosion problem but don't want to make the investment, which can often be very significant cost-wise in a nitrogen generator or a dry air generator. So what you do is you would put this corrosion monitoring device into your system, and like I said, George will explain how that works, but it goes into a couple different places in the system, and that way and then you just have an air compressor on it. If corrosion starts to take place to a point where it's going to affect the system negatively, then there will be a color change that takes place, and then you know that you have a corrosion problem that needs to be addressed. But you could go years without that. You could also go permanently without that because you don't have a significant corrosion issue. So, and in that regard, employing these corrosion monitor devices from AGF will certainly be the more cost-effective way to go. So I think that that's a good combination of a corrosion mitigation, a corrosion monitoring device alongside of an air compressor is a great way to address your corrosion issues when you're starting up a system. So another way to do that is with to address corrosion is with a dry compressed air generator. We call ours the dry air pack. Originally, it was built for freezer rooms and cold storage facilities, but dry air has inherent corrosion mitigation capabilities. So we do offer it as a corrosion mitigation solution quite often, actually. When certain scenarios play out, it becomes a better solution than a nitrogen generator. Now, there's other times where the nitrogen generator is the better solution. So again, in working with General Air Products, you have a lot of options. Maybe the answer is a air compressor with a corrosion monitoring device. Maybe the answer is a dry air generator. Maybe the answer is a nitrogen generator. The only place that, or the only people who can give you an objective opinion on all of those and tell you which is the best way to go is the people at General Air Products, because of the way that our product line works, which is offering all of these solutions. All right, so dry air generators remove moisture from compressed air. So when the compressor runs, it sends the air up through these desiccant beds. Let's see if I have a picture of those. No, not on this one. So let's go. There we go. Okay, so I didn't drop that one into my this presentation, but as the air goes up through the desiccant beds, and desiccant is the beads that you get in like packages with like new shoes or beef jerky or something like that that says "Do not eat." The desiccant there, it's in that so that it absorbs moisture, and for the shoes so that you don't get discoloration of the leather. In beef jerky, so that there's no funk on your beef jerky while you're, before you go to eat it, because beef jerky has some moisture in it. It's in a plastic bag. It sits around for a long time, and it's going to start to, get funky in there. So the whole point of that little desiccant bag with "Do not eat" is to reduce the moisture level in there. And that's essentially what we're talking about doing in inside of the piping system by putting dry air into the piping system. Is we reduce and eliminate the amount of moisture that's in the air there, thereby removing the possibility of corrosion or reducing the possibility of corrosion, depending on how things, what site conditions they were. And that's where I'd like to call that out too, is that dry air provides a level of corrosion protection that varies from system to system. I think we talk about it a couple times in here, but basically the more leftover water, the less effective dry air is, and the better possibility or the better outcome you're probably going to have with a nitrogen generator. But in a properly pitched, properly drained system, where most of the water is getting out of the system after the fill tests and whatnot, a dry air generator is a great way to go to limit or inhibit corrosion. And lastly, again, and I make this point with every piece of equipment, every technology, maintenance is key. If you do not maintain the dry air pack, you will not get the dew point that you need. If you do not get the dew point that you need, you will not be mitigating corrosion. You will not be preventing ice plugs, which is what it was designed for. Just like if you do not do maintenance on a nitrogen generator, you're going to soil the membrane. It'll get water or particulate in it, and that will cause it to not make 98% nitrogen. If you don't make 98% nitrogen, then you are not effectively inhibiting corrosion. So, and you don't have a very good dew point if you're using it in another capacity. So anyway, that's dry air in a nutshell. Dry air offers very high flow, so there is some restriction. We do lose about 10 to 15% of the flow coming out of the compressor through the drying process, mostly a purge and regeneration process with how these units work. And what I'm showing you here is this blue one is ours that we designed for the fire protection market, but these other two are showing you that there's a lot of variety out there when it comes to dry air generation. in industrial capacities and stuff. Like one of the applications that I love, and this one down here in the this tan colored one was used for this, and that's for military equipment. So like, and this is where, you know, maybe if you can imagine how this works for the military equipment, you can understand how well this works for fire protection equipment. And that is that they have a lot of military machinery. Like, let's think of a row of tanks, because there was actually a picture of a row of tanks. And then on the business end of those tanks was a tube going into where the shells come out. And this whole row of tanks had this tube going into them, and there was a dry air generator hooked up to them. So as the dry air runs and it goes inside, what it's doing is keeping corrosion from forming inside the barrel of the tank, and also inside of the tank where all the electrical equipment is and stuff like that. It's reducing the moisture in the air. It's keeping the air very dry so the corrosion can't take place. So again, just like it's used in the military for tanks, it's used in the fire protection world. So, but there is additional maintenance over regular fire protection air compressors, just because this is a more complicated piece of equipment. It's so the desiccant needs to be changed every 3 years. So that's something to keep in mind. And then there's a couple filters on there that need to be changed annually. Yep, I think that's good for that slide. So again, what we're doing here as far as the corrosion triangle is concerned is we're eliminating or reducing the amount of water in the system so that corrosion can't take place. That's how it works in regards to the corrosion triangle. We'll move on to nitrogen generators. Generators provide, you know, in contrast, a quantifiable approach to corrosion mitigation. If you get your entire system up to 98% nitrogen, then you will not have corrosion taking place. Or, well, yeah, it mitigates corrosion, which means that it's significantly reduced corrosion. It's not completely eliminated, but it's significantly reduced. The trick is getting 98% nitrogen and keeping 98% nitrogen. Again, we talk about 98% nitrogen, making pipes like black iron last 60 years and galvanized last 100 years. That only works if you get and keep 98% nitrogen on every part of that system at all times. So, you know, make sure that you have it at the end. And, you know, another thing is, and you'll be seeing more coming out from us, but the branch lines are an issue. Are you getting 98% in your branch lines? So it's something that I would really, you know, caution everybody on when you're talking about how vital this is to have 98% nitrogen everywhere and know that you have 98% nitrogen everywhere in your system. You know, because if you're just looking at it at the beginning of the system or the end of the system, do you know that it's everywhere in between? And you got to make sure that it is, and what will happen to your system if it's not. So 98% nitrogen is effective. The purity, like I said, must always be maintained. An air compressor will run much more often because of the way that the flow works through there and going through the membrane. The membrane really takes a lot out of the flow away. So we have a significantly reduced flow, but once again, too, maintenance is key on these units. Maintenance. There are, you have the compressor maintenance that needs to be done because it does have a functioning, you know, basically a tank mounted oilless air compressor on them. On the larger ones, it's a tank mounted lubricated compressor on them. And so the maintenance must be done as far as standard compressor maintenance, but then there's also the additional nitrogen membrane maintenance, which is pre-filters that are before the membrane. And then, you know, there's a whole host of other things that are just standard maintenance procedures. But again, if you don't do the maintenance, you won't realize the benefit of the unit. It will not last a long time, okay? Here you can see the airflow through those pre-filters that I was mentioning and then into the membrane as the compressed air goes out of the compressor and goes to 98% nitrogen on the other side of the membrane. So again, nitrogen generators inhibit corrosion very effectively, especially in systems with poor pitch and little drainage. The negative aspects to a nitrogen generator, very low flow. What you do with a nitrogen generator, so you know, is that when you first get it, you're filling your system with standard air. You're bypassing this membrane, right? There should be another line on this diagram that goes right around all this stuff and goes right to the system. Okay, and that's how the generators meet the 30-minute fill-up time. The reason that they only meet the 30-minute fill-up time that way is because when you go through the membrane, you lose all your flow, almost all your flow, a significant amount of your flow. And when I'm talking about significant amount, I'm talking about over 90%, over 95% of your flow is lost in the nitrogen membrane. So yeah, so I would say, understanding that you bypass this for your 30-minute fill, then once your system is up to pressure and you're at your 30-minute fill, you then go through the membrane, and the membrane will then over time, or the air compressor will then over time run air through the membrane that weeps into the system, and over the course of some amount of time, some people say 14 days. I have a tough time with that number, but over, somewhere around 14 days plus, you get to 98% nitrogen at the end of the line. And that's something that you need to keep an eye on. Additional maintenance, filters, high cost. Again, a nitrogen generator costs a lot of money compared to a standard air compressor. Which is another argument to me for putting a standard air compressor in and then putting a corrosion monitoring device on there. Save yourself the money until you know you have the problem, and address it before it's a real issue, before you lose any pipe, which is something that is very much capable of happening when done properly. So nitrogen generators, I put an X over the water because they do have a low dew point, which does have a drying effect, but because the flow is so low, it really doesn't have a huge effect there, but it does have some effect. So in the interest of being correct here, I certainly will call that out. But really where the effect of nitrogen is on reducing the amount of oxygen that's in the system down to below 2%, because you're now have 98% nitrogen in there eventually over time. So something to keep in mind. Dave, questions?
I have one that just came in, Ray. It's just, you keep mentioning that there's a significant cost difference between the types of air supply. Can you, without getting too specific, can you give any more information on that? How much of a cost?
Oh yeah, sure. So I mean, usually a compressor for a couple thousand gallons is going to run. Let's see, our small compressors, I think in the field, I mean, you're looking at below $1,000 to when you get to the field for larger compressors, you're looking around $3,000–4,000 tops, and that's for systems up to like 2,000 gallons or so. When you're talking about nitrogen generators for the smallest systems, you're starting at anywhere between $5,000 and $7,000, and going up to for the largest systems up to $25,000–$35,000. So there's a big price difference there, and that's where again our message here, like and I want to go back to I mean a lot of times I get grief internally at General for being doom and gloom about nitrogen. But what I'm trying to do is express to everybody that these are all just pieces of equipment, and every piece of equipment has pros and cons. It has good things and bad things. And that's why it's really important, and what we think is really important is for you to know all of those pros and cons to help make the best decision given your certain application. So when it comes to price, that's a factor. It's a pro or a con, right? But if you have significant corrosion issues, then a compressor isn't necessarily the best way to go. You replace your pipe and put in a nitrogen generator. These are the things that's where we come at it with this stuff, is to say that there's a lot of options and there's a lot of different ways that these dry systems can be affected. So that's why there's a wide variety of equipment on there, and sometimes one of those positive or negatives there is cost. It can't be denied.
All right, thanks, Ray. That's it for now.
Yep. Okay, cool. Right on. So let's get into the flow of air or nitrogen versus system leak rates. When sizing a nitrogen generator, if a fill compressor is not included with the unit, you will still need one. Again, I was explaining that you don't fill the system with 98% nitrogen. You fill the system with an air compressor, and then you run the air compressor through the nitrogen membrane to make 98% nitrogen. And because the flow is so reduced, you would need a generator the size of a house to fill or a membrane the size of a house to fill a small dry system in 30 minutes. So that's why you fill it with air first and then bring in the nitrogen. This is the section of the standard that refers to the 30-minute fill-up time, and this dictates the flow in CFM. CFM stands for cubic feet per minute. If people aren't familiar with that, I sometimes get carried away on these things. We kind of live and breathe air compressors, so CFM is just a common part of our dialogue. So CFM is cubic feet per minute of air. That's how you measure volumes of air. So this section of the standard dictates the flow or CFM of the fire protection air compressor necessary to fill the system. So once we establish the flow to fill the system in 30 minutes, we need to know what flow will be required of the unit while it's in nitrogen mode or maintenance mode, is what we often refer to it as, maintenance mode. Because at this point, we're not filling the system, we're just trying to maintain the right pressure. And you need a certain flow in order to maintain the right pressure. So this is where we pull that information from. Okay. New systems fall under the following allowable leak rate, and that's 1.5 PSI for a 24-hour period. So basically, when an installing company puts a system together, they have to monitor the pressure gauge for a 24-hour period to make sure that it doesn't drop pressure more than 1.5 PSI in a 24-hour period. Okay. If it's an existing system, you're now have a 3 PSI every 2-hour test that's done every 3 years to make sure that the system is within compliance. And that works out to a 36 PSI over a 24-hour period allowable leak rate. So those are the parameters for the leak rates. And these are important because when you get a sheet, a project form from any of the nitrogen manufacturers, and this includes General Air Products, there's a checkbox on there. We ask for all kinds of information. We need your contact information. We need your customer's contact. We need the amount of systems. We need what pressure the systems are going to be kept at, the volume of those systems, that sort of stuff. Then there's going to be a question on there, is this a new system or existing system? And that's telling, depending on what you check in that box, is telling us what is our baseline allowable leak rate. Because if you check existing system, then our baseline allowable leak rate is 3 PSI every 2 hours, which is what it should always be. But because there's nothing in the standard right now, a lot of, I guess, historically, and people still do, we try to do this as little as possible. And we know, we're just kind of forced into it because it's part of the way that the world works, is that you could size for a new system leak rate. And that becomes a real issue to me. And it's something that we're trying to change in the standard so that we can only size to existing system leak rates. But right now, General Air is part of the problem that the other manufacturers are part of as well, which is sizing these for new system leak rates, that 1.5 PSI leak rate. And I'm going to demonstrate that to you, what that looks like in the coming slides here. But I would always recommend, and the problem is that it costs more to size by the existing system leak rate, but it's going to give you a larger generator that's going to have a higher cost, but it's going to size the unit properly. And that's really what, you have to look at this in terms of what's best for the system when you're using the nitrogen generator. So again, remember, filters restrict flow. So again, we have an air compressor on the right, so that's you're going to give you your full flow, but on the left, and then on the right, we have a dry air unit where we're taking that compressed air and we're putting it through desiccant beds, which you're going to lose some of your CFM, some of your airflow. Just like in a nitrogen generator, we have the air compressor on the back, and you can see here on the back is a Oilless tank-mounted air compressor, and the hoses that go into the cabinet are either bypassing this membrane or going right through the membrane. And when they go through the membrane, you're restricting flow. And that flow that is restricted is very quantifiable. So we're going to take a look at how that's quantified, given a sample dry system here. So the sample dry system that we're looking at is a 2,000-gallon system. Number of total risers will be 4 total risers. This is a 40 PSI system pressure, and total system capacity between all 4 risers is 5,000 gallons. And then we put down the total system volume of roughly 2,500 cubic feet. at pressure, and because we use that number for our own calculations. So the new system allowable leak rate is 1.5 psi per day, which we saw in the standard previously. And in this system, that works out to a 0.047 CFM leak rate, a 0.047 CFM leak rate, which is a very, very small amount of air that is weeping out of this system. So when we are sizing our air supply for this system, and we're sizing an air compressor, the correctly sized air compressor, again, is meant to meet the 30-minute fill, so that's at roughly 24 CFM. The correctly sized dry air generator is sized for, again, your 30-minute fill, so that's going to be roughly 21 CFM, okay? That's how much, and remember, we only need 0.047 to keep up in a maintenance mode, right? So after we do the 30-minute fill, we're still using that 24 and 21 CFM to keep up with leaks. Now, when you have a correctly sized generator and somebody checked off the new system checkbox, they get a nitrogen generator that's going to do roughly 0.6 CFM while it's in nitrogen mode. Okay, when it's in air mode, it's going to do 24 CFM, but that's for your 30-minute fill, right? And then you close that valve, you reroute the air through the nitrogen membrane so that you get nitrogen and you get corrosion protection. But the cost of the corrosion protection is all of that flow. So we're losing all that flow and we're getting it down to 0.6 CFM. So now keep in mind though that 0.6 CFM at this state is more flow than we need. So on day one, we're good. You know, we need a maintenance flow of a minimum 0.047 CFM, and we have 0.6 CFM. So we're doing fine on day one. We're doing good. Everything's sized right. Everything's running right. But understand that even with 98% nitrogen on a system, a leak rate will continue to grow. And the reason why is that corrosion isn't the only thing that causes system leaks, okay? Corrosion, let's call corrosion the #1 reason why systems leak. There's no data for that, but let's just say that that's what the #1 reason for corrosion system or corrosion in fire sprinkler systems is the #1 reason for leaks. Well, there's still reasons 2 through 200 why your system's going to leak. So some of those reasons: dried out gaskets, incorrect gaskets, cross-threaded connections, external corrosion, because internal nitrogen does not help external corrosion. Leaking drains, valves not seating properly, building use and movement, all of these things are reasons why you will have leaks that nitrogen doesn't fix, nor does dry air. You just have leaks. And those leaks are going to continue to grow year after year. So let's take our sample system and blow it out to 9 years, right? And I picked 9 years not because of anything significant other than it's a bunch of time, right? It's not a little bit of time. It's not an excessive amount of time. Every sprinkler system should last 9 years. And in my mind, it should be functioning properly at 9 years, right? There shouldn't be, when you have a 20-year-old system, there's certain things that are going to fall apart, and we all expect that. But at 9 years, everything that started day one should still be working. At 9 years, our leak rate has kicked up to 21 psi per day, okay? And that equates to a system volume loss of 0.65 CFM. Now, note my third point here is that the 36 psi per day is the allowable leak rate for NFPA 25. So we're still within the parameters of NFPA 25's allowable leak rate. But the problem is that our 0.658 CFM leak rate is beyond what our nitrogen generator size for a new system can keep up with. So if you size this for a new system, you're not violating the standard by going, you will pass your 3 psi every 2 hour or 3 psi every 2 hour test, but you won't have enough maintenance flow in order to keep up with the system pressure. So how do we combat that? The way to do it is by sizing for an existing system. Because if we take, again, the same scenario and we size for an existing system, we have 1.2 CFM. Now, granted, a 1.2 CFM nitrogen generator is twice the flow of the generator size for a new system. But that said, it's also going to be roughly twice the cost. So that's something to keep in mind. So why haven't anybody been talking about leak rates until General Air starts talking about the concern about leak rates? It's really if it's not broke, don't fix it mentality. Again, we have so much flow coming out of the air compressor and then dry air generators that when we get beyond when we get beyond the allowable leak rates here, what's it called? Sorry, I got distracted here, and my neighbor's outside distracting me. But anyway, the wonders of COVID, doing presentations in your living room. So so when we're what's it called? The leak rates haven't been a concern before now because again, we have so much flow coming out of the air compressor that it will keep up with a huge leak rate. When it comes down to what you see from a maintenance capacity. I mean, for the air compressor to be running once an hour, let's just say that the pressure switch is set for 10 psi differential. So 30 psi it kicks on, 40 psi it kicks off. There's a 10 psi differential. If you see that compressor running once an hour, that means you're losing 10 psi an hour, which works out to 240 psi per day. That's a huge pressure loss and a huge flow loss. But it's the air compressor can keep up with that because it has a huge amount of flow that it's putting out there. When it comes to a nitrogen generator in nitrogen mode, we have only 0.6 or 1.2 CFM that we're dealing with. It's a very, very low amount of flow in order to come back on this to keep up in the system with. So it's that's why it hasn't come up, I think, before now. And that's why we're trying to call attention to it, because it is a big difference. A lot of people think that they expect that the nitrogen generator is just, almost equivalent to an air compressor. And while it is basically an air compressor with a fancy filter on it, that fancy filter does really eat up a lot of your flow. And you can see here, I mean, you're losing anywhere between 95 and 97% of your flow, but you are getting 98% nitrogen. So what do? You can either fix the leaks, you can buy a larger unit, or in the case of a nitrogen generator, if you're already at the largest unit, you can switch to another technology, but that's what you can do. Dave, we got any questions there?
I've got a couple that I'm in the middle of trying to get back to. I can give you one real quick. Let's see. So somebody wants to know, how effective would a nitrogen generator or a dry air pack be if it's located outdoors? It would be protected in a shack by rain, but it's not temperature controlled. It may get colder. It looks like he's saying that it is heat controlled, but only above 40 degrees. Do you have any comment?
That's a good question. You certainly don't want to let these things get below 40 degrees, and that has to do with the motors on them. Motors don't function real well when you get into really low temperatures. So I would certainly want to keep it above 40 for the sake of the motor. That said, I'm trying to think I know that, and I'd have to look. So, I mean, certainly send me an email so I can get some more in-depth answers to you. But send me an email with this question, because I'd like to get more in-depth with it, because there is an effect on the purity of nitrogen and temperature. So if you have a higher temperature, the nitrogen purity and I believe flow through the membrane is better. But I got to check that. So I don't want to give any bad information out. So I would say send me an email so that I can get back to you on some with some researched information here. I don't want to go off the cuff with that.
All right, great. Right. He said he's going to send you an email. So yeah, we look forward
to it. Good stuff. Perfect. Okay, great.
There's a bunch more, Ian, but I don't want to hold you up. I think I can get to the rest of them. So
okay, perfect. Good. Yeah, because I got about 5 minutes before I'm going to hand it over to George here. So let's see. So how do we determine which technology is best for your application? So let's just go through these, and then I'll wrap it up and hand it over to George. So what we do here is there's a series of questions that I like to go through, and you can apply these to whatever application. So we apply them in longer forms of this presentation to a cold storage facility or a parking garage, and you get different results. But that said, you know, there's these questions that I have you ask, or I ask people to answer when they're coming up with a how to determine what air supply technology is best. They're very pragmatic. They're very field level kind of hands-on questions. Excuse me, that will get to that will get you to the right application, and that in conjunction with your own experience with fire sprinklers, with our experience when you work with General Air Products and you talk to us about what's going on there, you know, with your specific job or application or whatever. We can help you zero in, and we will use these questions to do so. So let's get into that. So, you know, one thing I guess, and this is why I say field level, because there's a difference between the way things are supposed to work and the way they actually do work, and that is a very philosophical difference between the you know, say NFPA 13 and NFPA 25. So one of those, I think it's important to keep that in mind. So as we, with that in mind, let's ask ourselves these questions. So first is this system prone to leakage over time? So does the building's use indicate there will be a lot of movement? Is the system often neglected? If those things are the case, then you can anticipate a lot of air leaks. If you anticipate a lot of air leaks that are non-corrosion related, is nitrogen the best way to go? It's a good question to ask yourself, because, you know, again, the whole point of nitrogen is to reduce the amount of corrosion so that you're not in there replacing pipe all the time because of significant corrosion. But what if you're in there chasing air leaks instead? Is that not just as expensive or just as time consuming or just as problematic? So that's the part that I would really try to, you know, that's why we're asking this question. Is the system prone to leakage over time? Non-corrosion related leakage. So, you know, oftentimes systems like data centers and museums are not prone to leakage over time. They're very, you know, it's a very safe, static environment. There's a lot of maintenance that's done on it, you know, things like that that are done to make sure that if there's pressure losses, dry rotted couplings, you know, if there's, you know, somewhere along the line you see some external corrosion taking place in these systems, you know, people address that right away. That said, freezer rooms, parking garages, loading docks, places where you find much more standard kind of dry and pre-action systems, you're going to see a standard amount of leaks that don't have to do with corrosion. And that's something to keep in mind. So the next question, how much corrosion do we expect to take place in a sprinkler system for this application? So it's a subtle but important difference between those two questions, and that one is that what I'm asking you there is consider your experience in the area. Let's say it's a business center and you've done 4 or 5 buildings in that business center, and now you're doing a new system at a new building in this same business center. You've had corrosion problems in all of those other systems. You can probably assume safely that you're going to have a corrosion problem in the new system as well. And you might as well address it right out of the gate with a nitrogen generator. Conversely, if you've had no problems with corrosion in that business center, and all those systems are fine, and you have maybe some corrosion monitors in there that have not ticked off after years, well, then you can probably take a look at that and say, well, I don't see much corrosion going on here. And this is field level, this is experience that you're calling on to make a good call on what the best air supply solution is going to be. Because there's no point in dealing with the negative aspects of a nitrogen generator if it's not going to be giving you the positive aspects, which is corrosion mitigation. And if you don't have corrosion, then you don't have really a problem. So these are the things to think about. Is the pipe accessible? So how difficult is it to find and repair air leaks? So is the system behind drywall? I mean, if you're going to have to chase down air leaks because you put a nitrogen generator on there, and it's starting to the system's starting to age and whatnot, or there's dry rotted couplings or all sorts of things like that. Now the nitrogen generator is alarming. You're going to have to go knocking holes in walls everywhere. Is that something that's accessible? That's something to keep in mind ahead of time. High security is another one. So like we have our equipment in a lot of, you know, very high-end government facilities around the world. they're not easily accessible. Um, you need certain clearance levels and all sorts of things to get through them. So that said, is that something that you want to be going back for? Sometimes that means it's a good idea to get a nitrogen generator or a dry air generator. Sometimes it means it's a bad idea. So, again, asking yourself these questions is going to be helpful. What is the intended life of the structure? I think this is really important. Again, I had made reference to the idea of 60 years for black iron and 100 years for galvanized if you apply 98% nitrogen for the entire length of that time frame. But the intended life of the structure, again, not everything's made to last forever, right? And I think everybody in construction is acutely aware of that. So I use these examples. A coffee, like a Starbucks, is going to be a Starbucks for like 5 years. Then it's going to be a nail salon. And then it's going to be a parking lot for something else. So what are we talking about? 60-year and 100-year solutions on the overhangs at a Starbucks for? It's just not. It's overkill. That said, a hospital or a university are going to be hospitals and universities or museums for a long, long time. They're not going to change, so they might as well be something that we have a long-term outlook on preserving the pipe for, which means that nitrogen might be a better solution there, or a corrosion mitigation solution might be better in those instances. Again, stadiums is another one that I like to bring up in these instances because stadiums, we always think about them as this super long-term thing, but they're about 25 to 35 years is the average life of a stadium. So how do we make these things last 25 or 35 years? Because then it's getting knocked down. Next question is maintenance routinely performed? Again, I know I brought up maintenance on every piece of technology that we went over. Maintenance. It's really important. If you're not doing maintenance on these things, they are going to fail prematurely. You're not getting the full life out of them. And when it comes to, and that's the same for air compressors, and it's increased for dry air, and it's increased for nitrogen. You need even more maintenance on those than you do a standard air compressor. So those things, it's absolutely vital to have maintenance done on these things. So is maintenance done on the system? Is maintenance done on these units? Because if it's not, I would call that a cause of corrosion. As it should be another point on the corrosion triangle. It's not triangle anymore. It's a corrosion square, and that's not as exciting. But that said, is maintenance routinely performed? System maintenance, unit maintenance, those things need to be looked at on the regular. All right, so I think I'm out of time here. I am out of time here. So let me just kind of zoom through this here and get to the end, which is those questions previous here. So this is the list of those questions. Again, I think that these are really vital for assessing the application at hand and finding the right air supply solution. And I just want to say again that at General Air Products, we are very happy to go through this stuff with you as you're designing a project or about to install something on a project, or and questioning whether or not you should maybe install a fire protection air compressor versus a nitrogen air generator or whatever. We sell them all. We're happy to sell them all. We wouldn't sell them if they weren't good. They're not good if you put them in the wrong application, though, and that's what's really important to take away. Again, I want to just reiterate before we wrap up here that customer care comes first. So this is our customer service team here. Please call us when you need us. Call us from the field. If you put in an order and you get a delivery time that you're not liking, call us and we'll see if we can help you out. We usually can. But I can't emphasize enough how accessible we are. And I know that people more and more get out of touch with that because they think that they're not going to talk to a real human being or they're not going to get any help. That is not the case here. We are very old school in that regard. We have real live human beings who know what they're talking about answering the phones. They will be able to help you. Again, we have our sprinkler system training center. I want you to understand that we have not just air compressors in there, but we have a full line of all the major manufacturers, dry valves, pre-action valves. We have a deluge valve now. We have Viking was kind enough to give us a pre-action cabinets for single and double interlock. We have residential. We have our residential pumps in there. We have several different wet valves. We have backflow. We have a fire pump. You saw some of the pictures of the fire pump here's one here. But we have nitrogen generator stuff. All of AGF's products are here, so they're testing drains and all the other things that they make because they're right down the road from us. So what we tried to make this place is a place where all the manufacturers can put all of their equipment. And so if you want to come in here and do training on a variety of equipment, you have a variety of equipment here to do that. It's not just one manufacturer; it's all manufacturers. So we've been trying to be very open like that, and it's working out really well. I'm very much looking forward to stuff coming back. Again, go to training.generalairproducts.com, and you will find information about when we start those classes again. And that's my email address. If you want to just send an email directly to me, rmfjr at generalairproducts.com. And again, you can always call into the 800 number and get hold of anybody there. We'll be able to help you at General.